Hi everyone, I wanted to make a video about expected value because that question has come up in our discussion post a couple of times. So first I want to point out what expected value is, and this is from the lecture slides for this section, Lecture 5, Probability Distributions. So expected value, if we look at the calculation, it is the exact same as the calculation for, going back a couple slides, the same as the calculation for mean. And when we talk about mean for a data set, we're talking about the number in the middle, the number we can expect to see the most often, where most of the numbers are surrounding. And it tends to be this like sort of what we can expect when we look at our data. What we change when we start talking about probability distributions is we change essentially semantics. We stop calling it a mean and we start calling it expected value. Because even though it's the same as a calculation for the mean, it's not based on data, so it can't tell us the middle of the data set, but it can tell us what we should expect to happen on average. So that's why it gets renamed as expected value, because it's no longer based on a data set, now it's based on probabilities. So I want to go through this homework problem and talk about how to calculate it and how to interpret the calculation. So this homework problem is particularly tricky because it's not giving us the values that we use to do the calculations. It's giving us sort of the word problem, right? And that we have to interpret to be able to do the calculations. So this one is talking about a game of roulette. A player can place a $6 bet on the number 19 and have a 1 out of 38 probability of winning. If the metal ball lands on 19, the player gets to keep $6 and the player is awarded additional $210. Otherwise, the player is awarded nothing and the casino takes the $6. So in other words, if you win, you would net $210, but the casino actually hands you $216 because you get your bet back. So what we're worried about when we're trying to figure out expected value is what we're getting extra. So the $210, this net amount that we get back, is what we do our calculations with. If we lose, the casino takes our $6 and we're $6 in the hole, so that means we would have negative $6. So now we're tasked to find the expected value of this particular game. So I'm going to go ahead and do what I usually do is open Excel to help me out with my calculations. So first thing I'm going to do is say outcome and probability. So either, reading through the problem, I can win $210 or I can lose 6. We can add win, lose. Probability of winning is 1 out of 38. I'm saying it questioningly because I don't remember. 1 out of 38. And so the other probability must be 37 out of 38, because these have to be all the probabilities that you can possibly do. Okay, so we now need to do the expected value. So here we have the summation of x times p of x. And if we try and relate this back to our table, we didn't use any of these fancy math symbols, but we still have all of this stuff. So x is just the thing that's happening, and we call that outcome. Let's just rename it x so it's less confusing. So x has 2 possible outcomes. I get a whole bunch of money or I lose a little bit. And then we have probability of x, which we just nicknamed probability, but let's go ahead and rename that so it's less confusing to look at. Now this is distinctly the probability of these 2 outcomes. Now I have to multiply these 2 things together and then add them up. So equals this times this, and then the enter button. And I'm going to drag that down using my special skinny cursor. And then I just have to add them up, so I can go to this auto sum. So I can check the bottom corner, or I can go to the auto sum, and there's my answer right there. Now it's money, so I should round it appropriately. So I'm going to take away some of these decimals. Looks like I should expect to lose about 32 cents. So going back to the problem, I'm going to type in negative 0.32. Oh, and there's no follow-up. So let's just talk about what it means. So this means that if I keep standing there all day and just betting and betting and betting and betting, what I should expect to do is walk away from the table 32 cents in the hole, assuming that I stood there for a very long time, betting $6 continuously on the number 19 without changing anything up or going all red or, I don't know, switching to 18. This is what I should expect the outcome to be. So I should not expect to walk away with very much in my pocket, but also the loss isn't that bad. So again, we've switched the semantics. It's no longer average or mean because now we're talking about what we expect to happen. because we're no longer talking about a data set, we're talking about probabilities. And this is the expected outcome from standing at this table and betting in the exact way that is laid out in the problem. I hope you find that helpful, and I hope this video managed to clarify the difference between a mean and an expected value. So just one more time, a mean is based on a data set, so actual data that we collect when we measure a bunch of people's heights. Whereas expected value is based on a probability, because I haven't collected any data, so I can't say this is the average of data. I can only say this is what I expect to happen based on the probabilities.